Hello, and welcome. I'm so glad you're here with me tonight. Get yourself comfortable, settle into your favorite position, and let yourself relax. In this video, we're going to explore 100 fascinating facts about the universe together. Think of this as a gentle journey through space, where you can simply listen, let go, and drift off whenever you feel ready. There's no need to remember everything. Just let the words wash over you like waves. Let's begin. Fact 1. The universe is incredibly old. The universe is about 13.8 billion years old. That's a number so large, it's almost impossible to truly imagine. Think about it this way. If the entire history of the universe was compressed into a single year, human civilization would have appeared in the very last second, before midnight on December 31st. Everything we know, everything we've built, every person who has ever lived, all of it happened in that final tiny moment. Before that, there were billions of years of stars being born, galaxies forming, and cosmic events unfolding in the vast darkness of space. The universe has been here, evolving and expanding, for such an incredibly long time. It was here long before our sun existed, long before our planet formed, long before the first life appeared on Earth. And it will continue long after we're gone. There's something deeply peaceful about that thought. We are just a small part of this ancient, ongoing story. The universe doesn't rush. It unfolds slowly, patiently, over billions and billions of years. Time moves differently out there in the cosmos. A million years is just a blink. A billion years is just one chapter in an endless book. When you think about how old the universe is, it puts everything into perspective. Our worries, our stress, the things that keep us up at night, they're also temporary. They're just moments in an incredibly long story. So as you listen tonight, let yourself feel that perspective. Let yourself relax into the vastness of time. There's no hurry. The universe has been here for almost 14 billion years, and it's not going anywhere. Fact 2. The universe is still expanding right now. At this very moment, the universe is getting bigger. It's expanding in all directions, and it has been doing this since the very beginning. Scientists discovered this less than 100 years ago, and it changed everything we thought we knew about space. Imagine a balloon with dots drawn on it. As you blow up the balloon, the dots move away from each other. That's similar to how galaxies move apart as the universe expands. The space between them is literally growing. And here's the amazing part. The farther away a galaxy is from us, the faster it's moving away. Some galaxies are moving away from us so quickly that their light will never reach us. No matter how long we wait, they're beyond what we call the observable universe. The expansion is happening everywhere, all at once. It's not that galaxies are flying through space away from some central point. It's that space itself is stretching. New space is being created between galaxies constantly. This expansion is gentle and steady. You can't feel it, and it doesn't affect things on smaller scales like our solar system or even our galaxy. Gravity holds those together just fine. But on the largest scales, across billions of light years, the universe is growing. Scientists think this expansion might even be speeding up, driven by something mysterious called dark energy, but we'll talk about that later. For now, just picture it. While you're lying here, relaxing, getting ready for sleep, the universe around you is slowly, quietly, peacefully expanding. It's been doing this for billions of years, and it will keep doing it for billions more. There's something calming about that constant, gentle growth. The universe knows no hurry. Fact 3. Most of the universe is empty space. When you look up at the night sky, you see stars. You might see planets, the moon, maybe even a distant galaxy. But most of what you're looking at is actually nothing. Empty space. The universe is mostly vast stretches of emptiness with tiny islands of matter scattered throughout. Think about our own solar system. The sun is huge, and the planets orbit around it. But the distances between them are enormous. If the sun was the size of a basketball, Earth would be a tiny marble about 26 meters away, and the space between, nothing but vacuum. Now expand that to the galaxy. Our Milky Way contains hundreds of billions of stars, but they're separated by light years of empty space. A light year is the distance light travels in 1 year, and that's about 9 trillion kilometers. Between stars, there's mostly nothing, just cold, dark, empty space. And between galaxies, even more emptiness. Galaxies are separated by millions of light years of void. If you could stand in the space between galaxies, you would see almost complete darkness. Maybe a few faint smudges of distant galaxies, but mostly just black. This emptiness is peaceful in its own way. It's quiet. It's still. Nothing to disturb it. Nothing to interrupt the silence. In that emptiness, there's no sound, because sound needs air or some material to travel through. There's no temperature in the usual sense, because there's so little matter to be hot or cold. Just pure, undisturbed space. As you relax tonight, imagine that peaceful emptiness. Let your mind drift into that quiet void between the stars. Let yourself feel weightless, floating in that gentle darkness. Fact 4. There are more stars than grains of sand on Earth. This is one of those facts that sounds impossible, but it's true. There are more stars in the universe than there are grains of sand on all the beaches and deserts on Earth. Let's break that down. Scientists estimate there are about 100 billion galaxies in the observable universe. That's the part of the universe we can see. Each of those galaxies contains billions or even trillions of stars. Our own galaxy, the Milky Way, has somewhere between 100 billion and 400 billion stars, just in our galaxy alone. Now multiply that by 100 billion galaxies. The total number of stars is somewhere around 1 septillion. That's a 1 followed by 24 zeros. Meanwhile, all the grains of sand on Earth, from every beach, every desert, every sandbox, add up to roughly 7 quintillion grains. That's a 5 followed by 18 zeros. So yes, there are far more stars than grains of sand. It's hard to even comprehend numbers that large. Each one of those stars is a sun, potentially with its own planets, its own system. Many of them are larger than our sun. Some are smaller. Some burn hot and blue. Others glow cool and red. And they're scattered across unimaginable distances, filling the universe with light. When you look up at the night sky, you're only seeing a tiny fraction of them. Maybe a few thousand stars visible to your eyes. But they're out there, countless numbers of them, burning quietly in the darkness. Each one a world unto itself. As you drift off tonight, picture that vast sea of stars, more numerous than you could ever count. Each one shining steadily through the endless night. Fact 5. Light from distant stars takes millions of years to reach us. When you look at stars in the night sky, you're looking back in time. The light from those stars has been traveling through space for years, sometimes millions or even billions of years, before it reaches your eyes. Light is fast. It travels at about 300,000 kilometers per second. That's fast enough to circle the Earth 7.5 times in just 1 second. But space is so vast that even at that incredible speed, light takes a long time to cross it. The light from our sun takes about 8 minutes to reach Earth. So when you see the sun, you're seeing it as it was 8 minutes ago. The nearest star to us after the sun is Proxima Centauri, and its light takes 4.2 years to reach us. Other stars are much farther away. Some of the stars you can see in the sky are hundreds or thousands of light years away. That means you're seeing them as they were hundreds or thousands of years ago. And when we look at distant galaxies through telescopes, we're seeing them as they were millions or billions of years ago. Some of those galaxies might not even exist anymore in their current form. They might have changed, merged with other galaxies, or faded away. But we won't know for millions of years, because that's how long it takes their light to reach us. In a way, looking out into space is like looking into a history book. The farther you look, the older the history. It's a gentle reminder that nothing happens instantly on cosmic scales. Everything takes time. Light drifts slowly across the universe, carrying images of the past. And as you relax here tonight, imagine that light traveling through the darkness, patient and steady, taking its time to reach us. Fact 6. The Sun is just a medium-sized star. Our Sun feels enormous to us, and it is. It's about 109 times wider than Earth. You could fit over 1 million Earths inside it. But in the grand scheme of the universe, our Sun is actually pretty average. It's what astronomers call a yellow dwarf star. There are stars much, much larger. Some stars, called supergiants, are hundreds of times bigger than the Sun. The largest known star, Stephenson 2218, is so big that if you put it where our Sun is, its surface would extend beyond the orbit of Saturn. Light would take about 9 hours to travel around its circumference. That's almost incomprehensibly large. Then there are smaller stars too. Red dwarfs are the most common type of star in the universe, and they're much smaller and cooler than our Sun. Some are only slightly larger than Jupiter. They burn their fuel so slowly that they can shine for trillions of years, far longer than the current age of the universe. Our Sun is right in the middle, not too big, not too small. It's been shining steadily for about 4.5 billion years. And it has about another 5 billion years of life left in it. It's stable, predictable, and just the right size to support life on Earth. There's something comforting about that. Our Sun is just one of countless stars, nothing particularly special in the cosmic sense. But it's our star. It warms us, lights our days, makes life possible. It's been doing this quietly, reliably, for billions of years. As you rest tonight, think about that steady, warm light. Even now, while it's dark where you are, the Sun is shining somewhere, constant and unchanging. Fact 7. Black holes are not actually holes despite their name. Black holes aren't holes at all. They're incredibly dense objects with gravity so strong that nothing, not even light, can escape once it gets too close. Imagine taking all the mass of a star and crushing it down into a single point, or a very tiny space. The gravity around that point becomes so intense that it warps space and time around it. Anything that crosses a boundary called the event horizon is pulled in and can never escape. That's what makes a black hole black. No light can escape from it, so it appears completely dark. Black holes form when massive stars die. When a really big star runs out of fuel, it can no longer support itself against its own gravity. It collapses in on itself in a huge explosion called a supernova, and what's left behind can become a black hole. There are also supermassive black holes at the centers of most galaxies, including our own Milky Way. These can have the mass of millions or even billions of suns. Scientists aren't entirely sure how they formed, but they've been there for a very long time. Despite their reputation, black holes aren't cosmic vacuum cleaners. They don't go around sucking up everything nearby. Their gravity works the same as any other object with the same mass. If you replace the Sun with a black hole of the same mass, Earth would keep orbiting it exactly the same way, though it would be very cold and dark without sunlight. Black holes are mysterious and powerful, but they're also just another part of the universe. They follow the same laws of physics as everything else, and in the vast emptiness of space, they sit quietly, invisible, patient. As you relax tonight, there's no need to fear them. They're far away, doing their own thing in the cosmic dance. Fact 8. Time moves differently in space. This might sound strange, but time is not the same everywhere in the universe. According to Einstein's theory of relativity, time can speed up or slow down depending on how fast you're moving and how strong the gravity is around you. If you were on a spaceship traveling very close to the speed of light, time would slow down for you compared to someone on Earth. You might spend a year on the ship, but when you return to Earth, decades could have passed. This has been proven with very precise clocks on satellites. Similarly, gravity affects time. The stronger the gravity, the slower time moves. Near a black hole, where gravity is extremely strong, time slows down dramatically. If you watch someone fall toward a black hole from a safe distance, you would see them moving slower and slower as they approach the event horizon, almost as if they were frozen in time. Meanwhile, from their perspective, they would fall in at normal speed. This means time is not a fixed, universal thing. It's flexible, relative. It can stretch and compress. Clocks on GPS satellites actually run slightly faster than clocks on Earth, because they're farther from Earth's gravity. Engineers have to account for this, or GPS wouldn't work correctly. It's a strange concept, but it's real. Time flows like a river, but that river moves at different speeds in different places. As you lie here tonight, your experience of time is steady and calm. But out there in the universe, time is doing all sorts of interesting things, bending and shifting in ways we barely understand. Let that thought wash over you gently. Fact 9. The moon is slowly moving away from Earth every year. The moon drifts about 3.8 centimeters farther away from Earth. It's a very slow process, so slow that you'd never notice it in a lifetime. But over millions of years, it adds up. The reason this happens has to do with the tides. The moon's gravity pulls on Earth's oceans, creating the tides that rise and fall each day. But Earth's rotation also pulls on the moon through a phenomenon called tidal friction. This transfers some of Earth's rotational energy to the moon, causing it to slowly spiral outward. Billions of years ago, the moon was much closer to Earth. Days were shorter because Earth was spinning faster, and the moon looked much larger in the sky. The tides were much more extreme. Over time, both Earth's rotation and the moon's orbit have been changing gradually. Eventually, billions of years from now, the moon will be so far away that it will appear smaller in the sky, and Earth's rotation will have slowed down so much that a day might be as long as 50 hours. But this is happening so gradually that it's nothing to worry about. The moon has been our companion for over 4 billion years, and it will continue to orbit Earth for billions more, just a little farther away each year. There's something peaceful about that slow, steady drift. The moon isn't rushing anywhere. It's taking its time, just like everything else in the universe. As you relax tonight, think about the moon up there, pulling gently on the oceans, creating the tides, and slowly, imperceptibly, moving away into the darkness. Fact 10. There's no sound in space. Space is silent. Completely, utterly silent. On Earth, sound travels through air. When something makes a noise, it creates vibrations in the air molecules, and those vibrations travel to your ears. But in space, there's no air. There's no atmosphere, no medium for sound to travel through. So even if a massive explosion happened in space, you wouldn't hear a thing. This is one of the things movies get wrong. Those dramatic space battles with roaring engines and loud explosions. In reality, they would be completely silent. You might see the flash of an explosion, the bright light spreading out, but you'd hear nothing. Astronauts in space can only communicate through radio waves, which don't need air to travel. Inside their spacesuits or spacecraft, they can hear each other because there's air inside. But outside, in the vacuum of space, there's only silence. This silence is profound. It's a kind of quiet that doesn't exist on Earth, where there's always some sound, some movement of air. In space, between the stars and planets, there's absolute stillness. Nothing disturbs it. It's the deepest, most peaceful quiet imaginable. As you drift off to sleep tonight, imagine that silence. Let it surround you. Let it calm your thoughts. In the vast emptiness of space, there's no noise, no distraction. Just pure, gentle quiet. Fact 11. Saturn's rings are made of ice and rock. Saturn is famous for its beautiful rings, and they're truly spectacular. They stretch out hundreds of thousands of kilometers from the planet, but they're surprisingly thin, only about 10 meters thick in most places. The rings are made up of billions of pieces of ice and rock, ranging in size from tiny grains to chunks as big as mountains. These pieces orbit Saturn, reflecting sunlight and creating that bright, shimmering appearance we see through telescopes. Scientists aren't entirely sure how the rings formed. They might be the remains of a moon that broke apart, or they could be leftover material from when Saturn formed billions of years ago. What we do know is that the rings are relatively young in cosmic terms, maybe only a few 100 million years old. Saturn isn't the only planet with rings. Jupiter, Uranus, and Neptune all have ring systems too, but they're much fainter and harder to see. Saturn's rings are by far the most prominent and beautiful. If you could stand on one of Saturn's moons and look up, you'd see the rings stretching across the sky like a massive, glowing arch. It would be an incredible sight. The rings are constantly changing. The particles in them collide, break apart, and clump together. Some material falls into Saturn, while new material might be added from passing comets or asteroids. It's a dynamic, evolving system, but from our perspective on Earth, the rings look timeless and serene. They've been there for as long as humans have been able to see them, and they'll be there for millions of years to come. As you relax tonight, picture those rings, gently orbiting Saturn, catching the sunlight, peaceful and beautiful. Fact 12. Mars has the largest volcano in the solar system. On Mars, there's a volcano called Olympus Mons, and it's absolutely enormous. It's the tallest volcano and mountain in our entire solar system. Olympus Mons is about 25 kilometers high, which is almost 3 times taller than Mount Everest. And it's not just tall, it's also incredibly wide, stretching about 600 kilometers across. If you were standing on Mars and looking at Olympus Mons, you probably wouldn't even realize it was a mountain because it's so large. The slope is very gentle, only about 5 degrees on average. It would just look like a very gradual hill stretching to the horizon. Olympus Mons is what's called a shield volcano. It formed over millions of years as lava slowly flowed out and piled up, layer after layer. Mars has lower gravity than Earth and no plate tectonics, so volcanoes there can grow much larger than they ever could on our planet. On Earth, volcanic hotspots move as tectonic plates shift, creating chains of volcanoes. But on Mars, the hotspot stays in one place, allowing a single volcano to grow to enormous heights. Olympus Mons is probably extinct now. It hasn't erupted for millions of years, and Mars is geologically quiet these days. But at one time, it was active, pouring out massive amounts of lava and shaping the Martian landscape. It's a reminder that Mars was once a very different place, more active and dynamic than the cold, dry desert it is today. As you rest tonight, picture that massive volcano, silent and still, towering over the red sands of Mars. It's been there for billions of years, a monument to the planet's fiery past. Facts 13. Venus is the hottest planet, not Mercury. You might think Mercury, the closest planet to the Sun, would be the hottest, but it's not. That title goes to Venus. Venus is the second planet from the Sun, but its surface temperature is about 470 degrees Celsius, hot enough to melt lead. Mercury, despite being closer to the Sun, has temperatures that range from very hot during the day to very cold at night. It has almost no atmosphere to trap heat. During the day, Mercury's surface can reach about 430 degrees Celsius, but at night it drops to minus 180 degrees Celsius. Venus is different. It has a thick atmosphere made mostly of carbon dioxide, with clouds of sulfuric acid. This creates a runaway greenhouse effect. Heat from the Sun gets trapped in the atmosphere and can't escape, causing the temperature to rise to extreme levels. The atmospheric pressure on Venus is also crushing, about 90 times the pressure at Earth's surface. That's like being a kilometer underwater in Earth's oceans. If you stood on Venus, you'd be simultaneously cooked, crushed, and dissolved by the acidic atmosphere. It's one of the most hostile environments in the solar system. Venus is often called Earth's twin because they're similar in size, but that's where the similarity ends. While Earth is a paradise for life, Venus is a hellish inferno. It's a reminder of how delicate the conditions for life really are. As you relax tonight, be grateful for Earth's gentle atmosphere, the air you breathe, the comfortable temperatures. Venus might be beautiful from a distance, shining brightly in the sky, but up close, it's a nightmare. Fact 14. Jupiter protects Earth from asteroids. Jupiter, the largest planet in our solar system, acts like a cosmic shield for Earth. Its massive gravity attracts and deflects many asteroids and comets that might otherwise come our way. Jupiter is so big that it has more than twice the mass of all the other planets combined. Its gravity is incredibly strong, and it pulls in a lot of space debris. Some asteroids and comets get captured by Jupiter and crash into it. Others get their orbits changed, sending them away from the inner solar system where Earth is. Without Jupiter, Earth would likely be hit by many more asteroids and comets. These impacts could be devastating, causing mass extinctions and dramatically changing life on our planet. In fact, some scientists think Jupiter's protective influence has been crucial in allowing complex life to evolve on Earth. Of course, Jupiter doesn't catch everything. Some asteroids and comets still make it through. Earth has been hit many times in its history. The impact that killed the dinosaurs 65 million years ago is a famous example. But without Jupiter, impacts would probably be much more frequent. You can think of Jupiter as a big brother, standing guard at the edge of the neighborhood, keeping the smaller planets safe. It's been doing this job for billions of years, quietly and steadily. We don't often think about it, but we owe Jupiter a lot. As you drift off to sleep tonight, picture that giant planet, silently orbiting the sun, pulling in space rocks, protecting our little blue world. Fact 15. Neutron stars are incredibly dense. Neutron stars are among the strangest objects in the universe. They form when a massive star explodes in a supernova, and the core that's left behind collapses under its own gravity. What remains is a star made almost entirely of neutrons, packed together incredibly tightly. A neutron star is only about 20 kilometers across, roughly the size of a city, but it contains more mass than the Sun. That means it's incredibly dense. A single teaspoon of neutron star material would weigh about 1 billion tons. If you could somehow bring that teaspoon to Earth, it would instantly sink through the ground and fall toward the center of the planet. The gravity on a neutron star is so strong that if you tried to stand on one, you'd be instantly flattened into a layer of atoms. Even light has a hard time escaping. The surface gravity is about 1 billion times stronger than Earth's. Neutron stars also spin extremely fast. Some rotate hundreds of times per second. When they do this, they emit beams of radiation from their poles. If those beams point toward Earth, we see regular pulses of radio waves, and we call these objects pulsars. They're like cosmic lighthouses, spinning and sending out beams across space. Despite their small size, neutron stars are some of the most powerful and extreme objects in the universe. They're the leftover hearts of dead stars, compressed to the absolute limit of what matter can withstand before collapsing into a black hole. As you relax tonight, think about how strange and wonderful the universe is. Neutron stars remind us that reality is often stranger than fiction. Fact 16. The Milky Way is on a collision course with Andromeda. Our galaxy, the Milky Way, is heading toward a collision with the Andromeda galaxy. Don't worry, though. This won't happen for about 4 billion years, and when it does, it won't be as violent as it sounds. Andromeda is the nearest large galaxy to us, about 2.5 million light-years away. Both galaxies are moving through space, and they're being pulled toward each other by gravity. Eventually, they'll merge together to form one giant elliptical galaxy. When galaxies collide, the stars themselves rarely crash into each other. Space is so vast, and stars are so far apart, that they mostly just pass by each other. What happens is that the galaxy's shapes change. Stars get flung into new orbits, gas clouds collide and form new stars, and the whole structure of both galaxies is transformed. It's actually quite a beautiful process. Simulations show swirling spirals of stars, long tails and streams stretching out into space. Bursts of new star formation lighting up the galaxies. It takes millions of years for the galaxies to fully merge. For anyone living in either galaxy during the collision, the night sky would look different over time. You might see Andromeda growing larger and larger in the sky over millions of years, until it fills a huge portion of the heavens. Then, as the galaxies interpenetrate, the sky would be filled with bright new stars and nebulae. Our sun and solar system will likely survive the collision, though we might end up in a different part of the merged galaxy. By that time, the sun will be nearing the end of its life anyway. As you rest tonight, imagine those two giant galaxies, slowly drifting together across the void, pulled by invisible forces, dancing a cosmic dance that will last for billions of years. Fact 17. There are billions of Earth-like planets for a long time. We didn't know if planets existed around other stars. Now, thanks to modern telescopes, we know that planets are common. Very common. Almost every star has at least one planet orbiting it, and among those countless planets, many are similar to Earth in size and temperature. Scientists estimate there are billions of Earth-like planets in our galaxy alone. Planets that orbit their stars at the right distance for liquid water to exist. Planets that might have atmospheres, maybe even life. We've discovered thousands of exoplanets so far, and the list is growing all the time. Some are huge gas giants like Jupiter. Some are small and rocky like Earth. Some orbit very close to their stars, scorched and barren. Others are far away, cold and frozen. But many are in what we call the habitable zone, the region around a star where conditions might be just right for life as we know it. Of course, being in the habitable zone doesn't guarantee life. A planet needs the right atmosphere, the right chemistry, the right conditions, but the fact that there are so many possibilities is exciting. Somewhere out there, on a planet orbiting a distant star, there might be oceans, clouds, maybe even forests and creatures we can't yet imagine. We haven't found definite signs of life beyond Earth yet, but we're looking. And the more we learn, the more it seems likely that we're not alone. The universe is too big, too full of planets, for Earth to be the only place where life arose. As you drift off tonight, think about those distant worlds. Some of them perhaps looking up at their own night sky, wondering if they're alone. Fact 18. The universe might be infinite. We don't know if the universe has an edge, or if it goes on further. The part we can see, the observable universe, is finite. It extends about 46 billion light-years in every direction from us. But that's just the part we can observe. Beyond that, there's more universe. We just can't see it because the light hasn't had time to reach us yet. The universe could be much, much larger than the observable part. It might even be infinite, stretching on further in all directions. Scientists have tried to measure the shape and size of the universe, and so far, it looks like it might be flat and infinite. But we can't be sure. It's one of the great mysteries. If the universe is infinite, that means there's no center and no edge. Every point in space is essentially the same as every other point on the largest scales. No place is special. Earth isn't at the center, and neither is any other location. It also means there could be infinite galaxies, infinite stars, infinite planets. In an infinite universe, anything that's possible will happen somewhere, infinitely many times. There could be infinite versions of Earth, infinite versions of you. It's a mind-bending thought. On the other hand, the universe might be finite but unbounded, like the surface of a sphere. You could travel in a straight line forever and never reach an edge, but you'd eventually come back to where you started. We simply don't know yet. As you relax tonight, let your mind drift into that vastness. Whether the universe is infinite or just incomprehensibly large, it's far bigger than we can ever truly grasp. And that's okay. You don't need to understand it all. Just let it be. Fact 19. Dark matter makes up most of the universe's mass, When scientists calculate the mass of all the stars, planets, gas, and dust in the universe, they find something strange. There's not enough visible matter to account for the way galaxies move, and the way gravity works on large scales. Galaxies spin so fast that they should fly apart, based on the amount of matter we can see. But they don't. Something else is holding them together. That something is called dark matter. We can't see it, because it doesn't emit, absorb, or reflect light. It doesn't interact with normal matter in any way we can easily detect. But we know it's there because we can see its gravitational effects. Dark matter makes up about 85% of all the matter in the universe. That means the stuff we can see, all the stars and galaxies and everything we're made of, is only about 15% of the total. The rest is this invisible, mysterious dark matter. Scientists don't know what dark matter is made of. It's not atoms like the matter we're familiar with. It might be some exotic particle we haven't discovered yet. Experiments are underway to try to detect it directly, but so far, it remains elusive. Dark matter is everywhere. It forms a kind of invisible scaffolding throughout the universe, and normal matter clumps around it, forming galaxies and stars. Without dark matter, the universe would look completely different. Galaxies might not have formed at all. It's humbling to realize that most of the universe is made of something we don't understand. There's so much we still don't know. But that's part of the wonder of science and exploration. As you rest tonight, imagine that invisible substance filling the space around us, holding the cosmos together. Fact 20. Dark energy is pushing the universe apart. If dark matter is mysterious, dark energy is even more so. Not only is the universe expanding, but that expansion is speeding up. Galaxies are moving away from each other faster and faster as time goes on. This was discovered in the late 1990s, and it shocked scientists. They expected the expansion to be slowing down because gravity should pull everything back together. Instead, it's accelerating. Something is pushing the universe apart, and we call that something dark energy. Dark energy makes up about 68% of the total energy in the universe. Dark matter is about 27%, and normal matter is only about 5%. So the vast majority of the universe is made of things we don't understand. Dark energy seems to be a property of space itself. As space expands, more dark energy appears, which causes space to expand even faster, which creates more dark energy, and so on. It's a runaway effect. If this continues, the universe will keep expanding forever, growing colder and more spread out over trillions of years. Eventually, galaxies will be so far apart that beings in one galaxy won't be able to see any others. The universe will become a lonely, dark place. But that's in the very, very distant future. For now, dark energy is just gently, steadily pushing things apart. We don't know what it is or why it exists. It might be related to the energy of empty space itself, something called vacuum energy. Or it might be something else entirely. As you relax tonight, think about that gentle push, that mysterious force spreading throughout the universe, giving space room to grow. It's been working quietly for billions of years, and it will continue for billions more. Fact 21. Jupiter has a giant storm that's lasted hundreds of years. Jupiter has a famous feature called the Great Red Spot. It's a massive storm, bigger than Earth, that's been raging for at least 350 years, maybe much longer. The storm is an anticyclone, similar to a hurricane on Earth, but much, much larger and longer lasting. It's been observed by astronomers since the 1600s, when telescopes were first powerful enough to see it. At its largest, the Great Red Spot was about 3 times the size of Earth. It's been shrinking over the years, and now it's closer to 1.5 times Earth's size. Scientists aren't sure why it's shrinking, but it's still a massive and powerful storm. The winds in the Great Red Spot blow at speeds of up to 450 kilometers per hour. The storm rotates counterclockwise, taking about 6 Earth days to complete one rotation. The red color comes from complex chemicals in Jupiter's atmosphere, though scientists aren't entirely sure which chemicals are responsible. On Jupiter, storms can last for centuries because there's no solid surface to slow them down. On Earth, hurricanes lose energy when they hit land, but Jupiter is a gas giant with no solid ground. Storms just keep going, driven by the planet's internal heat and the energy from the sun. Jupiter has other storms too, some of them almost as big as the Great Red Spot. The planet's atmosphere is a turbulent, swirling mass of clouds and storms, constantly changing. It's a dynamic, active world. As you drift off to sleep, imagine that giant storm, swirling endlessly in Jupiter's thick atmosphere, a feature that's been there longer than any human civilization. Fact 22. The sun will eventually become a red giant. Our sun won't shine forever. In about 5 billion years, it will run out of hydrogen fuel in its core. When that happens, the sun will start to change. It will begin fusing helium instead of hydrogen, and this will cause it to swell up into a red giant. A red giant is a late stage in a star's life. The sun will expand enormously, growing to maybe 100 times its current size. It will become cooler on the surface but much larger overall. When this happens, the sun will likely engulf Mercury and Venus. Earth might be swallowed too, or it might just barely survive at the edge of the sun's outer layers. Either way, Earth will be scorched and lifeless. The oceans will boil away, the atmosphere will be stripped off, and our beautiful blue planet will become a barren rock. But this is billions of years away. By that time, life on Earth will have faced many other challenges. The sun is actually getting brighter very slowly even now, and in about 1 billion years, it will be hot enough that Earth's oceans will evaporate. So we have time, but not infinite time. After the red giant phase, the sun will shed its outer layers, creating a beautiful planetary nebula. The core that remains will become a white dwarf, a small, dense star about the size of Earth, but much heavier. It will slowly cool down over trillions of years, eventually becoming a cold, dark black dwarf. The sun's life cycle is peaceful in its inevitability. Stars are born, they shine for billions of years, and then they die. It's the natural order of things. As you rest tonight, don't worry about the distant future. The sun has been shining steadily for 4.5 billion years, and it will shine for billions more. Right now, it's doing its job perfectly, warming our planet, making life possible. Fact 23. There are clouds on other planets. Earth isn't the only planet with clouds. Venus has thick clouds made of sulfuric acid that completely cover the planet. These clouds are so dense that you can never see the surface of Venus from space. The clouds reflect a lot of sunlight, which is why Venus appears so bright in our sky. Mars has clouds too, though they're much thinner than Earth's. Most Martian clouds are made of water ice, similar to cirrus clouds on Earth. Sometimes Mars has clouds of carbon dioxide ice as well, and occasionally, huge dust storms engulf the entire planet, creating clouds of dust that can last for months. Jupiter and Saturn have spectacular cloud systems. Jupiter's atmosphere is filled with bands of clouds at different altitudes, made of ammonia and water vapor. The different colors come from different chemicals and different temperatures. Saturn's clouds are similar, but softer and more muted in color. Uranus and Neptune have clouds made of methane ice crystals. These give the planets their blue-green color. Neptune even has clouds that appear and disappear, including some very bright, fast-moving clouds that scientists call companion clouds. Titan, Saturn's largest moon, is the only moon in our solar system with a thick atmosphere, and it has clouds made of methane and ethane. It even has rain, though it's not water rain. It's liquid methane falling from the sky, creating rivers and lakes on Titan's surface. Clouds are one of those things that connect different worlds. Whether it's water vapor on Earth, sulfuric acid on Venus, or methane on Titan, clouds form when gases cool and condense. It's a simple physical process. but it creates such beautiful and varied features across the solar system. As you relax tonight, picture those alien clouds drifting through strange skies on worlds so different from our own. Fact 24. Galaxies come in different shapes. Galaxies aren't all the same. They come in a variety of shapes and sizes. Astronomers classify them into a few main types based on their appearance. Spiral galaxies are probably the most famous. They have a central bulge and long, winding arms that spiral outward. Our Milky Way is a spiral galaxy. The arms are filled with young, bright stars and lots of gas and dust where new stars are forming. Spiral galaxies are often very beautiful and photogenic. Elliptical galaxies are shaped like footballs or spheres. They don't have the distinct arms of spiral galaxies. Instead, they're smooth and featureless, filled mostly with old, red stars. Elliptical galaxies can range from small to absolutely enormous. The largest galaxies in the universe are giant elliptical galaxies. Irregular galaxies don't have a clear structure. They're messy and chaotic, often the result of galaxies colliding or interacting with each other. The Large and Small Magellanic Clouds, which are small galaxies near the Milky Way, are examples of irregular galaxies. There are also lenticular galaxies, which are sort of in between spiral and elliptical. They have a disc-like spiral galaxies, but no distinct arms. The shape of a galaxy depends on its history. Spiral galaxies are usually younger and still actively forming stars. Elliptical galaxies are often older, having used up most of their gas and dust. Irregular galaxies are often being pulled and distorted by the gravity of nearby galaxies. Each galaxy is unique, shaped by billions of years of cosmic evolution. As you drift off to sleep tonight, imagine those countless galaxies, each with its own shape and story, scattered throughout the universe like islands in an infinite ocean. Fact 25. The speed of light is the cosmic speed limit. Nothing can travel faster than light. This is one of the fundamental rules of the universe, according to Einstein's theory of relativity. Light travels at about 300,000 kilometers per second in a vacuum. And that's the absolute speed limit for anything in the universe. The reason nothing can go faster than light has to do with how mass and energy work. As an object with mass speeds up, it gains energy. But according to relativity, this energy also adds to the object's mass. The faster you go, the more massive you become, and the more energy you need to go even faster. As you approach the speed of light, your mass approaches infinity. And you'd need infinite energy to actually reach light speed. So it's impossible. Only things with no mass, like photons of light, can actually travel at light speed. Everything else has to go slower. This speed limit has big implications. It means there's a limit to how quickly information can travel. It means that distant parts of the universe are effectively cut off from each other. Even if we had perfect technology, we could never travel to a galaxy a billion light years away and come back. It would take too long. But this speed limit also creates a kind of cosmic order. It prevents paradoxes and keeps cause and effect working properly. If you could travel faster than light, you could theoretically travel backward in time, which would create all sorts of logical problems. The universe has rules, and the speed of light is one of them. It's been this way since the beginning, and it will always be this way. As you relax tonight, think about light racing through space, as fast as anything can possibly go, carrying information and energy across the cosmos. Fact 26. Asteroids are leftover building blocks of planets between Mars and Jupiter. There's a region of space filled with asteroids. This is called the asteroid belt, and it contains millions of rocky objects ranging in size from tiny pebbles to dwarf planets, hundreds of kilometers across. Asteroids are leftovers from the formation of the solar system. When the solar system was young, there was a disk of gas and dust orbiting the sun. Over time, this material clumped together to form planets. But in the region between Mars and Jupiter, Jupiter's strong gravity prevented the material from forming a planet. Instead, it remained as countless small bodies, the asteroids. The asteroid belt sounds dangerous, but it's actually mostly empty space. The asteroids are spread out over a huge volume, and they're quite far apart from each other. If you flew a spacecraft through the asteroid belt, you'd probably never see an asteroid with your own eyes. They're too small and too far apart. The largest asteroid is Ceres, which is about 950 kilometers across. It's so big that it's classified as a dwarf planet. Other large asteroids include Vesta and Pallas. Most asteroids are much smaller, just irregularly shaped chunks of rock and metal tumbling through space. Some asteroids have moons of their own. A few are actually binary asteroids, two rocks orbiting each other. Asteroids occasionally collide with each other, breaking into smaller pieces or sometimes merging together. Very rarely, an asteroid's orbit is disturbed and it ends up on a path toward the inner solar system. Some of these have hit Earth in the past, and they will again in the future. But most asteroids stay peacefully in the belt, orbiting the Sun in a slow, eternal dance. As you rest tonight, picture that vast belt of ancient rocks, remnants of a planet that never formed, quietly circling the Sun. Fact 27. Comets are dirty snowballs from the outer solar system. Comets are some of the most spectacular objects in the sky when they come close to the Sun. They develop long, glowing tails that can stretch for millions of kilometers. But comets are actually quite simple. They're basically dirty snowballs, lumps of ice and rock left over from the formation of the solar system. Most comets come from two regions far beyond the planets. The Kuiper Belt is a region beyond Neptune filled with icy bodies. Many comets come from here. Even farther out is the Oort cloud, a vast spherical shell of icy objects surrounding the entire solar system. Comets from the Oort cloud can take thousands or even millions of years to orbit the Sun. When a comet's orbit brings it close to the Sun, the ice starts to heat up and turn into gas. This creates a glowing cloud around the comet called a coma. The Sun's radiation and solar wind push the gas and dust away from the comet, creating the tail. The tail always points away from the Sun, no matter which direction the comet is moving. Some comets are periodic, meaning they return to the inner solar system on a regular schedule. Halley's Comet is the most famous example. It returns every 76 years. Other comets are seen once and then disappear back into the outer solar system, not to return for thousands of years. Comets are time capsules. They've been frozen in the outer solar system for billions of years, largely unchanged since the solar system formed. Studying them gives us clues about what the early solar system was like. They're ancient travelers, carrying ice and dust from the dawn of time. As you drift off tonight, imagine those icy wanderers, gliding through the darkness on their long journeys around the Sun. Fact 28. There are volcanoes on Io. Io is one of Jupiter's moons, and it's the most volcanically active body in the entire solar system. Its surface is covered with volcanoes, hundreds of them, constantly erupting and reshaping the moon's landscape. Io is about the same size as our moon, but it looks completely different. Instead of grey craters, Io has a colorful surface with yellows, oranges, reds, and blacks. These colors come from sulfur and sulfur dioxide erupted by the volcanoes. The volcanic activity on Io is driven by tidal heating. Jupiter's gravity pulls on Io, and so do the other large moons of Jupiter. These gravitational forces squeeze and flex Io as it orbits, creating friction and heat inside the moon. This heat melts rock and drives the volcanic eruptions. Some of Io's volcanoes are incredibly powerful. Plumes of gas and dust shoot hundreds of kilometers into space. The lava flows are hotter than anything on Earth, reaching temperatures of over 1700 degrees Celsius. The entire surface of Io is constantly being renewed by volcanic activity. Io has no impact craters, unlike most moons, because any craters that form are quickly covered by new lava flows. The surface is geologically very young, maybe only a few million years old on average. Despite all this activity, Io is a cold, airless world. It has a very thin atmosphere of sulfur dioxide, but nothing like Earth's atmosphere. If you could stand on Io, you'd see volcanoes erupting all around you. fountains of molten rock shooting into space, and Jupiter hanging huge in the sky overhead. It would be a surreal and dangerous place. As you relax tonight, picture Io, glowing with volcanic heat, a restless moon forever reshaped by the forces acting on it. Fact 29. Europa might have an ocean under its ice. Europa is another one of Jupiter's moons, and it's one of the most interesting places in the solar system. Europa's surface is covered with a thick layer of ice, crisscrossed with cracks and ridges. But beneath that ice, scientists believe there's a global ocean of liquid water. The evidence comes from several sources. Europa's surface is very smooth and young, suggesting it's being renewed. The magnetic field measurements suggest a conductive layer beneath the surface, which could be salty water, and the ice cracks show patterns consistent with a liquid layer underneath flexing and moving. The ocean on Europa could be 50 to 100 kilometers deep. That's much deeper than Earth's oceans. It would contain more water than all of Earth's oceans combined. And because it's beneath kilometers of ice, it's protected from radiation and the vacuum of space. This ocean is kept liquid by tidal heating, the same process that drives Io's volcanoes. Jupiter's gravity flexes Europa, creating heat inside. This heat keeps the ocean from freezing solid. Where there's liquid water and energy, there's the possibility of life. Scientists think Europa's ocean might have hydrothermal vents on the seafloor, similar to the ones on Earth where life thrives even in total darkness. We don't know if there's life on Europa, but it's one of the best places to look. Future missions might drill through the ice or analyze water that's erupted from cracks to search for signs of life. Europa is a small, icy moon, but it might harbor one of the most important discoveries in human history. As you drift off to sleep, imagine that hidden ocean, dark and deep, beneath the frozen surface, possibly teeming with life we've never seen. Fact 30. Pluto has a heart-shaped feature. Pluto was visited by NASA's New Horizons spacecraft in 2015, and the images it sent back were stunning. One of the most striking features is a large, heart-shaped region on Pluto's surface. Scientists informally call it Tombaugh Regio, after Clyde Tombaugh, who discovered Pluto. The heart is about 1,600 kilometers across, and it's divided into two parts. The western part, called Sputnik Planitia, is a smooth plain of nitrogen ice. It's very bright and appears to be geologically young, with no impact craters. Scientists think this ice is constantly being renewed through a process similar to convection, where warmer ice rises and cooler ice sinks. The eastern part of the heart is rougher terrain. Pluto itself is much more interesting than anyone expected. It has mountains made of water ice as tall as the Rockies. It has glaciers of nitrogen ice flowing across the surface. It has a thin atmosphere that freezes and falls to the surface as Pluto moves away from the Sun in its orbit. Pluto is very far from the Sun, about 5.9 billion kilometers on average. It's so far that sunlight there is very faint, only about 1/600th as bright as on Earth. Temperatures on Pluto are around -230 degrees Celsius. Despite being small and cold and far away, Pluto is a dynamic world. It has weather, it has seasons, it has geology. It's a reminder that even in the coldest, darkest corners of the solar system, there's beauty and complexity. As you relax tonight, think about little Pluto, so far from home, with its heart shining in the faint sunlight. Fact 31. The universe was once much hotter in the beginning. The universe was incredibly hot and dense. Right after the Big Bang, temperatures were billions and billions of degrees. Everything was just energy and fundamental particles. As the universe expanded, it cooled down. Within the first second, it cooled enough for protons and neutrons to form. After about 3 minutes, it was cool enough for these particles to stick together and form the first atomic nuclei, mostly hydrogen and helium, but it was still far too hot for atoms to form. The universe was a hot, glowing plasma, like the inside of a star, but filling all of space. Photons of light couldn't travel very far because they kept bouncing off the charged particles. The universe was opaque. This continued for about 380,000 years. Then, the universe cooled enough for electrons to combine with nuclei and form neutral atoms. Suddenly, photons could travel freely. The universe became transparent. The light from this moment is still traveling through space today. We can see it as the cosmic microwave background radiation, a faint glow coming from every direction in the sky. Over billions of years, the universe continued to expand and cool. The first stars formed, then galaxies, then planets. The hot, smooth plasma of the early universe gave way to the rich, complex cosmos we see today. But that ancient heat is still there, cooled down to just a few degrees above absolute zero, filling all of space. It's a reminder of where everything came from. As you drift off to sleep, imagine the universe in its infancy, glowing white hot, then slowly cooling, stars lighting up one by one in the darkness. Fact 32. Stars are born in nebulae. Stars don't just appear. They're born in vast clouds of gas and dust called nebulae. These clouds are often light years across and contain enough material to make thousands, or even millions of stars. A nebula is mostly hydrogen gas, the simplest and most common element in the universe, mixed in are heavier elements and tiny grains of dust. For most of the time, a nebula just floats in space, calm and still. But sometimes, something disturbs it. Maybe a nearby star explodes, sending out a shockwave. Maybe two clouds collide. Whatever the trigger, parts of the cloud start to collapse under their own gravity. As the cloud collapses, it fragments into smaller clumps. Each clump continues to collapse, getting denser and hotter. At the center of each clump, a protostar forms. The protostar is not yet a true star. It's still gathering material and growing. But as it gets denser, the pressure and temperature at its core increase. Eventually, the core gets hot enough for nuclear fusion to begin. Hydrogen atoms start fusing into helium, releasing enormous amounts of energy. The protostar ignites and becomes a true star. The whole process takes millions of years. The leftover gas and dust around the new star might form planets, or it might be blown away by the star's light and wind. The nebula itself is gradually used up, as more and more of its material goes into making stars. We can see this happening in places like the Orion Nebula, one of the closest star-forming regions to Earth. Telescopes have captured images of young stars still surrounded by disks of gas and dust. It's a nursery where new stars are being born right now. As you relax tonight, think about those stellar nurseries, where light and life are beginning, where the next generation of stars is taking shape. Fact 33. Red dwarfs can live for trillions of years. Red dwarf stars are the most common type of star in the universe. They're small, cool, and dim compared to stars like our sun. But what they lack in brightness, they make up for in longevity. A red dwarf can live for trillions of years. Our sun will live for about 10 billion years total, and it's already halfway through its life. But red dwarfs burn their fuel so slowly that they can shine for 100 trillion years or more. That's longer than the current age of the universe by a factor of thousands. The reason red dwarfs live so long is because they're so efficient. They're small, so they don't have as much fuel to begin with. But they use that fuel very slowly. They also mix their material thoroughly through convection, so they can use almost all of their hydrogen, not just the hydrogen in the core. This means that, in a sense, red dwarfs are immortal on human timescales. Every red dwarf star that has ever formed is still shining. None of them have died yet, because the universe simply isn't old enough. In the far, far future, long after stars like the sun have all burned out, red dwarfs will be the only stars left. They'll be the last lights in the universe, shining alone in the darkness. Eventually, even they will run out of fuel and fade away. But that won't be for trillions upon trillions of years. Red dwarfs are patient. They take their time, burning slowly and steadily, outlasting everything else. As you drift off to sleep tonight, think about those tiny, humble stars, glowing quietly in the darkness, destined to be the longest-lived objects in the cosmos. Fact 34. The sun loses mass every second. The sun is constantly losing mass. Every second, it converts about 4 million tons of matter into energy through nuclear fusion. This might sound like a lot, but compared to the sun's total mass, it's tiny. The sun weighs about 2 times 10 to the power of 30 kilograms. Losing 4 million tons per second is like losing a grain of sand from a mountain. At this rate, the sun could shine for billions of years before it runs out of fuel, which is exactly what it will do. The mass is lost because of Einstein's famous equation, E equals mc squared. Energy and mass are interchangeable. When the sun fuses hydrogen into helium, a tiny bit of mass is converted into a huge amount of energy. That energy radiates out into space as light and heat. The sun also loses mass through the solar wind, a stream of charged particles that flows out from the sun in all directions. This carries away a small amount of mass as well. Over the sun's lifetime, it will lose a significant amount of its total mass. By the time it becomes a white dwarf at the end of its life, it will have lost about half of its original mass. But for now, the sun is stable and steady. It loses mass, but so slowly that it doesn't affect its behavior or its ability to warm our planet. The sun has been doing this for 4.5 billion years, and it will continue for billions more. As you relax tonight, think about the sun, slowly converting itself into light, giving itself away piece by piece to warm the solar system. Fact 35. There's a supermassive black hole at the center of our galaxy, at the very center of the Milky Way. There's a supermassive black hole. It's called Sagittarius star, and it has a mass of about 4 million suns. This black hole doesn't do much most of the time. It's relatively quiet, just sitting there at the galactic center. But we know it's there because we can see stars orbiting around it at incredible speeds. Scientists have tracked individual stars orbiting Sagittarius star for years. Some of these stars move so fast that they complete an orbit in just a few years, even though they're light years away from the black hole. The speeds and orbits of these stars tell us exactly how massive the black hole is. Most large galaxies have supermassive black holes at their centers. These black holes can have masses of millions or even billions of times the sun's mass. Scientists think they formed early in the history of their galaxies and grew over time by consuming gas, dust, and stars. Some supermassive black holes are actively feeding. They're surrounded by disks of hot gas spiraling inward, and they emit enormous amounts of energy. These are called active galactic nuclei, and they can outshine the entire rest of the galaxy. But Sagittarius star is quiet. It's not feeding much. Occasionally it flares up a little when something falls in, but mostly it's dormant. It's just there, a massive, invisible presence at the heart of our galaxy. Everything in the Milky Way orbits around it, slowly, over hundreds of millions of years. We're orbiting it right now. Our solar system takes about 230 million years to complete one orbit around the galactic center. As you drift off tonight, think about that slow, vast orbit, the sun and all its planets circling the heart of the galaxy. Fact 36. Gravity affects the flow of time. We've talked about how time can slow down near massive objects, but it's worth exploring this idea a bit more. Gravity literally bends time. The stronger the gravity, the slower time moves relative to someone in weaker gravity. This has been tested and proven many times. Scientists have flown atomic clocks on airplanes and found that they tick slightly faster at high altitude than clocks on the ground, because gravity is slightly weaker up there. GPS satellites have to correct for this effect constantly, or they'd give the wrong positions. If you lived on the top floor of a tall building, you'd age very slightly faster than someone living on the ground floor. The difference is tiny, measured in nanoseconds over a lifetime, but it's real. Near a black hole, the effect is extreme. If you watch someone fall toward a black hole's event horizon, you'd see them moving slower and slower. Time itself is slowing down for them from your perspective. They would appear to freeze, approaching the horizon but never quite reaching it. Meanwhile, from their perspective, they'd fall in at normal speed. It's one of the strangest predictions of relativity, and it's been confirmed by observations. Time is not absolute. It flows differently depending on where you are and how you're moving. This can be hard to wrap your mind around, because our everyday experience makes time seem constant and uniform. But out in the universe, time is flexible. As you relax tonight, let yourself feel the strangeness of it. Time flowing at different rates in different places, a river with varying currents, all part of the fabric of space-time. Fact 37. The coldest place in the universe, the coldest natural place we know of in the universe, is the Boomerang Nebula. It's a cloud of gas expelled from a dying star, about 5,000 light-years away from Earth. The temperature there is about 1 degree above absolute zero. Absolute zero is the coldest temperature theoretically possible, -273.15 degrees Celsius. At absolute zero, atoms would stop moving entirely. Nothing in the universe can actually reach absolute zero. But the Boomerang Nebula comes very close. It's colder than the background temperature of space itself, which is about -270.4 degrees Celsius. The nebula is so cold because of how it formed. The dying star at its center expelled gas very rapidly, and as the gas expanded, it cooled dramatically. It's the same principle that makes spray cans feel cold when you use them. The gas in the Boomerang Nebula is expanding so fast that it's cooled below the temperature of the cosmic microwave background radiation. In laboratories on Earth, scientists have created even colder temperatures using lasers and special techniques. They've cooled atoms to billionths of a degree above absolute zero. At those temperatures, matter behaves in very strange ways, forming exotic states like Bose-Einstein condensates. But in nature, out in space, the Boomerang Nebula holds the record. It's a ghost of a dying star, cooling silently in the darkness, colder than anything else in the cosmos. As you drift off to sleep, imagine that profound cold, that absolute stillness where even atoms barely move. Fact 38. Some moons have atmospheres. When we think of atmospheres, we usually think of planets. But some moons have atmospheres too. Titan, Saturn's largest moon, has the thickest atmosphere of any moon in the solar system. It's actually thicker than Earth's atmosphere. Titan's atmosphere is mostly nitrogen, like Earth's, but it also contains methane and other organic molecules. The atmospheric pressure at Titan's surface is about 1.5 times that of Earth. If you stood on Titan, you wouldn't need a pressure suit, just something to provide oxygen and keep you warm. The atmosphere is so thick that it completely hides Titan's surface. From space, Titan looks like a smooth, orange ball. We can only see the surface using radar or infrared instruments that can penetrate the haze. Triton, Neptune's largest moon, has a very thin atmosphere of nitrogen and methane. Io has an extremely thin atmosphere of sulfur dioxide created by its volcanic eruptions. Even Europa has a tenuous oxygen atmosphere, though it's far too thin to breathe. Our own moon has essentially no atmosphere, just a few scattered atoms. But some moons are more Earth-like than we might expect. Titan, in particular, is fascinating. It has clouds, rain, rivers, and lakes, though they're made of liquid methane and ethane rather than water. It has seasons, weather patterns, and a complex chemistry. Some scientists think Titan might be similar to early Earth before life began. Studying Titan helps us understand how chemistry and geology work in environments very different from our own. As you relax tonight, picture those distant moons, some shrouded in thick hazes, some with wispy atmospheres, each one unique. Fact 39. The universe has no center. You might imagine the universe expanding outward from some central point, like a bomb exploding. But that's not how it works. The universe has no center and no edge. This is hard to visualize, but think about the surface of a balloon again. Imagine drawing dots on the balloon to represent galaxies. As you inflate the balloon, the dots move away from each other. But there's no dot that's at the center of the expansion. Every dot sees the other dots moving away from it. Each dot can think of itself as the center. The universe is similar, except it's in 3 dimensions rather than on a 2-dimensional surface. Every point in the universe sees galaxies moving away from it in all directions. There's no special point that's the center of the expansion. This means that Earth isn't at the center of the universe. Neither is any other galaxy. Every location is essentially equivalent. You could be anywhere in the universe, and it would look pretty much the same on the largest scales. Galaxies in all directions, expanding away from you. This is related to something called the cosmological principle. The idea that the universe is homogeneous and isotropic on large scales. That means it looks the same everywhere and in every direction. There's no preferred location or direction. It's a bit unsettling to think that there's no center, no reference point. But it's also democratic in a way. No place is special. We're all part of the same expanding cosmos. As you drift off to sleep, let go of the need for a center. The universe doesn't need one. It simply is, expanding everywhere at once. Fact 40. Stars shine in different colors if you look carefully at the night sky. You'll notice that stars aren't all the same color. Some are blue-white, some are yellow, some are orange or red. The color of a star tells you its temperature. Hot stars are blue or blue-white. They burn at temperatures of 20,000 degrees Celsius or more. Medium temperature stars like our sun are yellow or white, with temperatures around 5,000 to 7,000 degrees Celsius. Cool stars are red or orange, with temperatures of 3,000 degrees Celsius or less. This might seem backward. We usually think of red as hot and blue as cold, but in stars, it's the opposite. Blue stars are the hottest, red stars are the coolest. This is because of how objects emit light when they're heated. As something gets hotter, the wavelength of the light it emits shifts toward the blue end of the spectrum. Very hot objects glow blue, cooler objects glow red. The color also gives us information about a star's age and size. Blue stars are usually young and massive. They burn their fuel quickly and don't live very long, maybe only a few million years. Red stars are often old or small. Red dwarfs are small and cool, and they live for trillions of years. Red giants are old stars in the late stages of their lives. When you look at a star cluster, you can see stars of many different colors all together. It's like looking at a snapshot of stellar evolution. The blue stars are the young ones, living fast. The yellow stars are middle-aged, like our sun. The red giants are the old ones, nearing the end of their lives. As you relax tonight, picture that rainbow of stars, each one a different color, each one at a different stage of its journey. Fact 41. Galaxies can merge. Galaxies don't stay isolated forever. They interact with each other, and sometimes they merge. We've already talked about how the Milky Way will eventually collide with Andromeda, but galaxy mergers happen all the time throughout the universe. When two galaxies get close, their gravity pulls them together. They orbit around each other, gradually spiraling inward. Over hundreds of millions of years, they merge into a single larger galaxy. During a merger, the shapes of both galaxies are distorted. Long tails and streams of stars get pulled out into space. The gas clouds in the galaxies collide, triggering massive bursts of star formation. Millions of new stars are born in a relatively short time. The supermassive black holes at the centers of both galaxies eventually merge as well, creating an even more massive black hole. This process releases gravitational waves, ripples in spacetime that we can detect with special instruments. After the merger is complete, the new galaxy settles down. If two spiral galaxies merge, they usually form an elliptical galaxy. The beautiful spiral arms are lost, replaced by a smooth, featureless blob of stars. Galaxy mergers were more common in the early universe when galaxies were closer together. Today, the universe is more spread out, so mergers are less frequent, but they still happen. Astronomers have observed many galaxies in various stages of merging. Some look like they're barely touching, just starting to interact. Others are a chaotic mess of stars and gas, deep into the merger process. Each merger is unique, a cosmic dance of gravity and matter. As you drift off to sleep, imagine those vast galaxies, slowly coming together. They're billions of stars rearranged, creating something new. Fact 42. The Earth's atmosphere protects us. Earth's atmosphere is a thin layer of gases surrounding the planet, and it's absolutely essential for life. It provides the oxygen we breathe. It shields us from harmful radiation. It keeps the planet warm, and it creates weather patterns that distribute water around the globe. The atmosphere is mostly nitrogen, about 78%. Oxygen makes up about 21%, and the remaining 1% is argon, carbon dioxide, and trace amounts of other gases. This mixture is perfect for life as we know it. One of the most important jobs of the atmosphere is blocking radiation. The sun emits not just visible light, but also ultraviolet radiation, X-rays, and other high-energy particles. Too much of this radiation would be deadly. The ozone layer, a part of the atmosphere rich in ozone molecules, absorbs most of the ultraviolet radiation. Without it, we'd get severe sunburns in minutes and have much higher rates of skin cancer. The atmosphere also protects us from meteorites. Small rocks from space constantly hit the Earth, but most of them burn up in the atmosphere before reaching the ground. We see them as shooting stars. Only the larger ones make it through. The atmosphere also acts like a blanket, trapping heat from the sun and keeping the planet warm. Without it, Earth would be frozen, with average temperatures far below freezing. The greenhouse effect, caused by gases like carbon dioxide and water vapor, keeps Earth habitable. Of course, too much greenhouse effect is a problem, as we're seeing with climate change. But the basic principle is that the atmosphere regulates temperature and makes life possible. As you relax tonight, take a deep breath. Feel the air around you. This thin shell of gas is all that stands between us and the vacuum of space. It's precious and fragile. Fact 43. Sunsets on Mars are blue on Earth. Sunsets are red and orange. But on Mars, sunsets are blue. This strange effect happens because of the dust in Mars' atmosphere. Mars has a very thin atmosphere, mostly carbon dioxide, with a lot of fine dust suspended in it. During the day, the Martian sky looks reddish or butterscotch-colored because the dust scatters red light. But at sunset, something interesting happens. The sun's light passes through more atmosphere when it's low on the horizon. The dust particles scatter the red and yellow light, letting the blue light pass through. So around the sun itself, you see a blue glow. It's the opposite of Earth, where the blue light is scattered away, leaving the red and orange. Astronauts and rovers on Mars have captured images of these blue sunsets, and they're hauntingly beautiful. The sun appears smaller and dimmer than on Earth because Mars is farther from the sun, and that blue halo around it creates an alien, otherworldly scene. Imagine standing on the dusty plains of Mars, watching the sun set. The sky darkens from butterscotch to deep red, but around the sun, there's a patch of soft blue light. The landscape is bathed in a strange twilight. It's quiet. There's no sound but the faint wind. No birds, no insects. Just you and the alien sunset. Mars is a beautiful world in its own way. It's harsh and cold and hostile to life, but it has moments of stunning beauty. Those blue sunsets are one of them. As you drift off to sleep tonight, picture yourself standing on Mars, watching the blue sun sink below the horizon. Fact 44. There are planets that orbit to suns. You might remember the iconic scene from Star Wars, with two suns setting on the horizon. It turns out that's not just science fiction. Planets that orbit binary star systems really exist. These are called circumbinary planets. In a binary star system, Two stars orbit each other. If a planet orbits both stars, it has two suns in its sky. Scientists have discovered dozens of these planets using the Kepler Space Telescope and other instruments. One famous example is Kepler 1.6b, a gas giant about the size of Saturn. It orbits two stars, one about 2/3 the mass of our Sun and another about 1/5 the Sun's mass. The two stars orbit each other every 41 days, and the planet orbits both of them every 229 days. If you could stand on Kepler 1.6b, which you can't because it's a gas giant, you'd see two suns moving across the sky together. They'd rise and set as a pair, sometimes eclipsing each other. The lighting would be complex and constantly changing. Some circumbinary planets are in the habitable zone, meaning they're at the right distance for liquid water to exist. Could life develop on such a planet? We don't know, but it's possible. The environment would be different from Earth, with varying amounts of sunlight as the two stars moved around each other. But life is adaptable. Binary star systems are actually quite common. About half of all stars are in binary or multiple star systems, so circumbinary planets might be common too. There could be countless worlds out there with double sunsets. As you relax tonight, imagine standing on one of those worlds, watching two suns cross the sky, casting double shadows, creating a dance of light unlike anything on Earth. Fact 45. The Sun's core is under immense pressure deep inside the Sun. At its core, the pressure is about 250 billion times the atmospheric pressure on Earth. The temperature there is about 15 million degrees Celsius. Under these extreme conditions, nuclear fusion occurs. Hydrogen atoms are squeezed together so tightly that they overcome their natural repulsion and fuse into helium. This releases enormous amounts of energy. The energy created in the core doesn't escape immediately. It takes thousands or even hundreds of thousands of years for that energy to work its way to the surface. Photons of light are created in the core, but they can't travel in a straight line. They bounce around, getting absorbed and re-emitted countless times as they slowly migrate outward. By the time the energy finally reaches the Sun's surface, it's been transformed. The high-energy gamma rays from the core have become visible light and heat. This light then travels through space at the speed of light, reaching Earth in about 8 minutes. So the light warming your face on a sunny day started its journey in the Sun's core hundreds of thousands of years ago, during the last ice age or even earlier. It's been on a long, slow journey through the layers of the Sun before finally escaping into space. The Sun's core is a place of unimaginable violence and energy. Nuclear reactions happening constantly, matter being converted into energy, all contained by the Sun's own gravity. Yet from the outside, the Sun looks calm and steady. It's been shining peacefully for billions of years, and it will continue for billions more. As you drift off to sleep, think about that hidden furnace, buried deep inside the Sun, quietly powering everything we see. Fact 46. Water ice exists on the Moon for a long time. Scientists thought the Moon was completely dry. It seemed logical. The Moon has no atmosphere to protect it, and sunlight would evaporate any water on the surface. But in recent years, we've discovered that there's water ice on the Moon, hidden in permanently shadowed craters near the poles. These craters never see sunlight. They're in eternal darkness, and temperatures there drop to -250 degrees Celsius. In these freezing shadows, water ice can survive. Some of this ice might be billions of years old, deposited by comets that crashed into the Moon. The discovery of water ice on the Moon is exciting for several reasons. First, it tells us about the history of the Moon and how water gets distributed in the solar system. Second, and more practically, it could be a resource for future Moon bases. Water is heavy and expensive to launch from Earth. If we can use water that's already on the Moon, it makes lunar exploration much easier. The ice could be melted and purified for drinking water. It could be split into hydrogen and oxygen for rocket fuel or breathing air. It could support crops in lunar greenhouses. Having water on the moon changes what's possible. There's not a huge amount of it, and extracting it from permanently shadowed craters would be challenging. But it's there, waiting in the darkness, a resource left behind by ancient comets. As you relax tonight, think about those dark craters, colder than anywhere on Earth, holding precious ice from the dawn of the solar system. Fact 47. Spacecraft have visited every planet. Human-made spacecraft have now visited every planet in our solar system. This is an incredible achievement. In just a few decades, we've gone from barely reaching space to exploring the entire solar system. Mercury was visited by Mariner 10 in the 1970s, and more recently by Messenger and Bepi Colombo. Venus has been visited by many Soviet and American spacecraft. Mars has been explored by numerous rovers and orbiters. Jupiter and Saturn have been visited by Pioneer, Voyager, Galileo, and Cassini spacecraft. Uranus and Neptune were both visited by Voyager 2, which is the only spacecraft to have flown by those distant worlds. Pluto, no longer classified as a planet but still beloved, was visited by New Horizons in 2015. These missions have revolutionized our understanding of the solar system. Before we sent spacecraft, we could only observe planets through telescopes. We had rough ideas about their size and orbits, but we didn't know what they really looked like up close. Now we have detailed maps of every planet. We've seen volcanoes on Mars and Io. We've seen the rings of Saturn up close. We've measured the atmospheres of Venus and Titan. We've discovered moons we didn't know existed. Each mission has revealed surprises. Jupiter's moon Europa probably has an ocean. Saturn's moon Enceladus has geysers, shooting ice into space. Pluto turned out to be geologically active, despite being frozen and far from the sun. These spacecraft are humanity's emissaries, traveling to worlds no human has ever walked on. Some of them are still out there, like Voyager 1 and 2, which have left the solar system and entered interstellar space. They carry messages from Earth, golden records with sounds and images of our world, hoping that someday, someone might find them. As you drift off tonight, think about those lonely spacecraft, traveling through the darkness, sending back knowledge from the farthest reaches of our cosmic neighborhood. Fact 48. Stars can explode when a massive star runs out of fuel. It doesn't just fade away quietly. It explodes in one of the most energetic events in the universe, a supernova. For a brief time, a single supernova can outshine an entire galaxy. Supernovae happen when a massive star, at least 8 times the mass of the Sun, exhausts its nuclear fuel. The star has been fusing elements in its core, creating heavier and heavier elements. First hydrogen to helium, then helium to carbon and oxygen, then all the way up to iron. But iron is different. Fusing iron doesn't release energy, it takes energy. So once the core is iron, there's no more fuel. The core can no longer support itself against gravity. In less than a second, the core collapses. Protons and electrons are squeezed together to form neutrons. The core becomes incredibly dense, and then it rebounds. The outer layers of the star come crashing inward, hit the rebounding core, and are blasted back outward in a massive explosion. The supernova ejects most of the star's mass into space, at speeds of thousands of kilometers per second. The shockwave from the explosion creates new elements, heavier than iron: gold, platinum, uranium. All the heavy elements in the universe were created in supernovae or similar events. The material from the exploded star spreads out into space, mixing with nearby gas clouds. Eventually, this material gets incorporated into new stars and planets. The Earth, and everything on it, including you, is made of atoms that were forged in stars and scattered by supernovae billions of years ago. You are literally made of stardust. As you relax tonight, think about that. The atoms in your body came from stars that lived and died long before our sun was born. Fact 49. The Voyager probes carry messages from Earth. Voyager 1 and Voyager 2, launched in 1977, are now in interstellar space, beyond the influence of the Sun. They're the most distant human-made objects, over 20 billion kilometers from Earth. These spacecraft were designed to explore Jupiter and Saturn, which they did successfully, but they kept going, and Voyager 2 went on to visit Uranus and Neptune as well. Now, they're traveling out of the solar system, into the space between the stars. Both Voyagers carry a golden record, a phonograph disc containing sounds and images from Earth. The record includes greetings in 55 languages, music from different cultures, natural sounds like wind and surf and birdsong, and 116 images showing life and culture on Earth. There are also diagrams showing Earth's location in the galaxy, and instructions for how to play the record. The golden records were designed to communicate with any intelligent beings who might find the spacecraft someday. Of course, the chances of that happening are incredibly small. Space is vast, and the Voyagers are tiny. They'll drift through the galaxy for billions of years, probably never coming close to another star. But the gesture is beautiful. It's a message in a bottle, thrown into the cosmic ocean, saying we were here. This is who we are. The records also serve as a time capsule for humanity. They represent Earth as it was in 1977, a snapshot of our world. As you drift off to sleep, imagine those spacecraft carrying humanity's greetings, traveling through the endless dark, silent and alone. Fact 50. Time dilation makes space travel complicated. If we ever want to travel to distant stars, we'll have to deal with the effects of special relativity and time dilation. As we discussed earlier, time slows down for objects moving at very high speeds. If you were on a spaceship traveling at a significant fraction of light speed, time would pass more slowly for you than for people on Earth. Imagine you took a trip to a star 10 light-years away at 90% of light speed. For you, the trip might only take a few years because time has slowed down for you. But on Earth, decades would pass. When you returned, everyone you knew might be much older or even dead. This is called the twin paradox, and it's not really a paradox, it's just how relativity works. The closer you get to light speed, the more extreme the effect. At 99% light speed, time would slow down by a factor of about 7. At 99.9%, it's about 22. This means interstellar travel is possible in principle, but it comes with a cost. The travelers would be young, but they'd return to a very different Earth. This makes space exploration deeply poignant. To reach the stars, we'd have to leave our time behind. As you rest tonight, think about the strange nature of time and space, how they're woven together, how speed affects the flow of time itself.